This video covers topic 11.5 over rational exponents. There are a few quick vocab words that you need to understand. If we say the word degree, the degree means the number of times the radicand is multiplied by itself. It is the number that is listed on the outside. The radical symbol is the square root symbol. We normally talk about square root. It is the length of the horizontal bar is important. How far it stretches is important. And then the radicand is the thing you are finding the square root of. So working our way from outside in, degree, radical symbol, radicand. Now, in order to understand, if we are asked to put something into radical form, radical meaning the square root, they mean put it in square root form. Exponential form means only exponents, do not put any square roots, and you might need to convert from one to the other. So this rational exponent idea is found on your formula chart. This is on the very bottom of it, of the exponent section. And it shows us that a to the m over n. So with a fraction, n goes on the outside, m stays on the inside with the base. So for these examples, they're asking us to convert from exponential to radical. So get rid of the exponents if possible and put it in a square root. What you're going to do is take your base, the denominator of your fraction and pull it outside, and whatever's left stays on the inside. So 4 to the 5th. So 4 and the top part of our fraction stay in the square root. The bottom of my fraction goes on the outside. So similar thing here. 4 is going to go on the outside of the square root. 5x is going to stay in parentheses, and negative 3 goes on the inside. Goes on the inside with the rest of our radicand. So again, our pattern here is whatever the denominator of our fraction is in the exponential form goes on the outside, everything else follows and goes on the inside. So for this problem, 3 goes on the outside, 7 to the 4th goes on the inside. Now to go the other way to exponential form, whatever's on the outside goes on the bottom of the fraction. Whatever's on the inside, so we have an invisible 1, goes on top, and the 3 stays where it is. So we get rid of the square root, 3 to the 1, pull up, and we put a base of, a bottom to my fraction of 2. So whatever's on the outside needs to be the bottom of my fraction. So 6 becomes the bottom of my fraction. Now that entire thing, km to the 5th, the entire thing needs to be raised to the 1/6 power, so that's why I just went ahead and put it on the outside rather than dealing with the 2k and the m. 3 goes on the outside and becomes the denominator, g and 2 stay as is. So what you could do is rewrite what you're seeing on the top and outside. Now this one's a little tricky. So for this one, 5 is on the inside, the 4 is on the inside, so that comes up and becomes 1/4, and then this whole thing is being raised to the 5th power. So that one's kind of ugly, so just be careful with that there. So write in radical form, meaning give it a square root. Get rid of that square root that we have there. Make a square root. Get rid of the fraction. So 3 goes on the outside, 4 to the 5th stays on the inside. It does matter how far you put that bar out. It does need to cover that whole thing. So make sure you are very careful you're not writing too sloppy. 2 goes on the outside. 3 to the 5th goes on the inside. Now, this is just a quick note. A square root is normally to the power of 2. So if you said something like this and you did not put the 2, that would be acceptable as well. 4 goes on the outside. 5x to the negative 3 goes on the inside. Now, like we talked about yesterday, we do have that rule where you have to get rid of negatives. So if you move the whole thing down to the bottom, that would get rid of your negative. And then for problem 4, this is 6v to the 7/2. So 2 goes on the outside. 6v to the 7th goes on the inside. On these, we're going back the other way, so whatever is on the outside becomes the bottom of my fraction. So what I was trying to say earlier, probably not very well, was what you can do is take your radicand that's under this square root and write that, and then just put it over the outside power. So take that 4 and put it here, and all you're doing is rewriting what's under the square root, getting rid of the square root, and putting what's outside the square root as the base of your fraction. So gn to the 7th, getting rid of your square root, writing what's on the outside of your square root on the base, or on the bottom. So problem 7, what's in the square root, and then writing the 7 as the base of your fraction. Note the difference between 6 and 7. On 6, the 7 is on the outside, so we put it on the outside. However, 3 is on the inside here, so we put it on the inside with our answer. So make sure you are paying attention for things like that. And then p to the 8, fraction 5, because the 5 comes over here, and we get rid of the square root and give it a fraction instead. And then the last problem, simplify the expression to exponential form. So put it in an exponent form. The function f of x equals 2 parentheses 2 cubed parentheses x can be simplified to be which function? So 2 is really a 1. We know that these are piggybacked, so this is 3x if we simplify. And then we know based on our multiplication rules that when we multiply, we really add our exponents. So 1 plus 3x, which would be d, just written in a different order.